Okay, we've got a pretty plain looking integral today from the MIT Integration Bee 2025 problem 10. We have the integral from 0 to 10, x times x minus half, x minus 1 dx. Okay, now to get started with it, I don't really have a lot of creative ideas for this one. If you multiply all this out, you're just going to have a polynomial and its power rule. So I'm not really coming up with anything here. The only thing I can think of that might be a little bit interesting, what if I multiply in a 2 just to clean that up a little bit? This really doesn't do very much though. And then we'll have like a 1/2 in front like that. Well, I still need to just multiply all this stuff out. So maybe there's a way to do a substitution or something, but I'm just not seeing it. So if you distribute this part out here, you're going to get 2x squared minus 3x plus 1. And then we still have this x here. Multiply that in, then we're going to have 2x cubed minus 3x squared plus x. So let's take this and put this back in our integral. So the 1/2, that's going to come out front as a constant. We're integrating from 0 to 10 of just the polynomial, which we can do with power rule. So they basically just gave us power rule on this one. I don't know. So we got 1/2 in front. Integrating this is going to become x cubed. Integrating this, it's going to become 1/2 x to the 4th minus, this just becomes x cubed. The 3 will cancel when it comes out in the denominator. This is going to be x squared over 2, evaluated from 0 to 10. When you plug in the 0, that's going to be nothing. When you plug, Now, when you plug 10 in, I think in one move I'll factor another 1/2 out just to try to simplify this. So what's going to happen when we factor that out? It's going to be 1/4 in front. Plug a 10 in here, that's going to be 10,000. Here, when we factor this 1/2 out, there's going to be a 2 here. So now it's going to be minus 2. 10 cubed is 1,000. And then here, plug that in, that's just going to be plus 100. Simplifying it, 10,000 minus 2,000 is 8,000 plus 100. We end up with 8,100 over 4. Divide that out, and for the final solution, you get just 2,025, and that's it. Okay, so I couldn't really see too much reason for this problem, but they did get 2025 in it. They also were able to match the bound to the problem number, so not a lot of math in it, but still, I feel like I had to do it because I'm trying to I want to at least do all 20 from the qualifying exam. So that's it for today. Thanks everyone for watching. Have a good day.